Dear all, welcome to this new episode of the CATIA TV, this time on the very strategic topic of 3D Experience CATIA Connected Engineering. Nowadays, there is an increased complexity to generate different products with a lot of different variants, and the processes and the ecosystems are more and more complex, with more demands on speed and price coming from OEMs and customers. Facing those trends, you need the right function, productivity, confidence, collaboration, and trust that you will get the right design until the very end. With 3D Experience CATIA, you will be able to do anything you need. Collaborate and share on a 3D Experience platform, working together on the same data, install and maintain ongoing projects without administration complexity, thanks to the cloud, succeed in creating complex design and high-quality complex mechanical shapes, improve the quality of your products while helping users to reach manufacturability criteria with best compromise in surface quality, optimize your manufacturing process by compensating forming deformation to bring virtual definition close to real-life definition, capitalize, automate, and reuse with CATIA KnowledgeWare applications, capture your knowledge and know-how and reuse it where it can be done by the experts and designers, access the right information directly in 3D for better compliance with regulations and standards, set in motion and validate your ideas by designing your products in motion with kinematics and structural insights. To conclude, 3D Experience CATIA is the best productive user experience you can ever dream of. This is the main differentiator of 3D Experience CATIA compared to the previous version of CATIA and to the competition. So, ready as a CATIA V5 user to jump in 3D Experience CATIA? Follow our CATIA subject matter expert, Daniel Pisac, with an exceptional CATIA TV with values and demonstration. As usual, the CATIA TV webinar will be held here, in the post where you are right now, in our CATIA user community, and it will give you the capacity to interact in live with our subject matter experts throughout the chat. So don't hesitate to watch the webinar and don't hesitate to ask questions. We wish you a very good day.
Hello everyone, my name is Daniel Pisac. I am very happy to be with you for this webinar regarding 3D Experience CATIA, Connected Engineering. The main idea here is to introduce to some of you, maybe disclose some nice secrets of 3D Experience CATIA for some of you too, regarding mainly the user interface of CATIA 3D Experience or 3D Experience CATIA. To design much more efficiently, and you will see it's much more easy than some other CAD modeler. And this is an episode, the episode 1. We will make more episodes in the future, mainly focus on assembly modeling or some other nice capability of 3D Experience CATIA. And I hope you will enjoy that. So it lasts around 30 minutes, not more. Let's start. So the idea is to show you how, if you were a 3D Experience CATIA user, you have to work. What are the steps to design this particular assembly? It's a braking system, braking caliper system. And at the end, how you can take into account some data that you receive from your supplier or maybe your customer, which are not maybe perfect, and how to clean and to take into account some design changes. Okay, so it's a little bit of part design for those who are familiar with CATIA, and a little bit of generative shape design for those, again, who are familiar with CATIA. Let's start by designing this assembly. So very first thing, I am in CATIA assembly design. So you can check here the workbench, the app I am using, and you can see that in 3D Experience CATIA, I can use very, very advanced rendering display, still with a very, very good response time, because this helps you to understand better your design context, okay? And you can see that I will use, for this particular presentation, almost not at all the spec tree that maybe you are familiar with, what we call the specification tree, where the history of the design is shown. I will not use icons which are spread out all over my screen, because the idea is to keep most of the display for the 3D, not for commands. But I use something which is called the action pad, where you can gather all the commands that you are mainly using during a design. It can be command from part design, which is a solid modeling from CATIA, or command from generative shape design, which is a surface modeling from CATIA, or maybe other apps. And you can gather them in an action pad. They are default action pad, by the way. And you can either dock them, like what is done here. I docked them on the right side, upper right side of my screen, or those action pads can be popped up just where my mouse is located, just by hitting the B key on the keyboard. It's not what I will use. I will use the docking capability of CATIA. Let's start. So this is my motorbike, and I want to work on this particular braking system, the brake caliper. Okay. First thing, I will select visually my context. I will define my working context, and you will see very also nice capability of 3DEXPERIENCE CATIA, which is a display of what I don't need in a ghost way. Okay, so what you see in dimmed or transparent white is in fact in a ghost mode. But at least I know where am I in my assembly, my full assembly. And I can, for example, add a new view in my working environment. The view, for example, of this context can be shift to another screen. You know, most of CAD users today are mainly use two screens. If you are using 3DEXPERIENCE CATIA, you use the two screens, either to display, for example, the assembly and your part, or some menus, because you can also dispatch some menus in other screens. So it's very, very flexible. So let's see what it does. So here I display, for example, my starting point. I start by defining a skeleton, which is a very traditional way of working with CATIA. And of course, I can see the skeleton at the part level, here on the left side of the screen, or at the assembly and context level on the right part of the screen. And there will be a permanent dual display of what I am designing. So let's start the design. Maybe you did not see that, but I click on a plane, and automatically CATIA prompts me, what do you want to do with the plane? Probably you want to do a sketch. And I say yes. So I don't have to go and click on the sketch icon, which might be somewhere, maybe in my action pad, or maybe not. You see here, sketch. Now I'm defining my sketch, and all my commands of the sketcher are also popping up in front of me, close to my mouse location and my click, and proposing to me some commands depending on what I clicked. This is what we call the contextual immersive commands. Very nice capability. So I start my sketch. As you see, so here I can also use the menus or the commands which are in the action bar, here on the lower level of the screen. This is typical design of my sketch. I define some constraints, some offsets. I define some fillets. I will also mirror this half sketch because I would like to have the complete sketch. And you see, I do not click. My mouse mileage is very limited. Okay. Here we go. I sketch. I do the mirror of this area, and now I leave the sketch. Okay. Of course, you can see that on the right side, you see exactly what I did at the sketch level. Now I click on the sketch. The sketch was selected. So CATIA proposed to me, you have selected a sketch. Maybe you want to make a pad, which makes sense. Yes, I want to make a pad. And then I just need to select the direction of the extrusion and the value, the thickness of the pad. And I directly type in the command, and CATIA creates a feature pad in the spec tree. Okay? You could have done exactly the same with a traditional, let's say, CATIA V5 way, where you click on command, the command pad, you have a dialog box popping up, you enter values, and then the feature pad is aggregated in the spec tree. But here it's much faster. Here you see here the pad dialog box that you can use if you want to add advanced more details in your pad feature. Here we go. I click on this plane. I accept the sketch. Here I just project an edge of this newly created pad into the plane. And I just add some constraints on my sketch to fix it, to dimension it. And I will create as I did earlier, another pad. This is the value of my fillet. Here's the sketch. As the sketch is aggregated or was constructed on a face of a solid, now I have two options. Do you want to create a pad or do you want to create a pocket? I create a pad, I select the direction and the thickness very easily. No dialog box, just everything is done directly on the graphics in 3D. I continue the design of my sketch and my solid. I am here in the sketcher of part design. I create some offsets. You see, it's very simple, very straightforward. At any time, if you need more advanced capability, you can use the advanced capability of your action pad. You can also hide the action pad. Here, I just create a pad to remove some material inside this block. And you see here on the screen why I did that, because I wanted to take some into account the brake disc itself. Makes sense. So it's why the context is very important. You never design a part alone. Okay, it's always inside a context within a given assembly. Here, by just clicking on a face and this line, I can create a hole because the input were the direction of the hole and the starting face. I just select regular holes. Here we go. Very nice capability also of 3DEXPERIENCE CATIA is that I can change at any time what we call ambience. You will see what I mean. An ambience can be, for example, a dark blue background. Traditional way of working with some CAD tools. But I can have a more fancy way. Maybe my part is designed inside a given context. You can define your own, let's say, context. And I can come back to the basic, which is white in this particular case. Now that I'm okay with that, I will just erase my context view and just work with the, let's say, design view. Here I can at any time undock some commands and dock them where I want on the screen. It's very simple. So you see here the refine command with the chamfer fillets. I can add as many commands where I want, and those menus can be also attached to another screen, for example, if you have two screens. And of course, if I am a little bit messy, I can come back to the predefined position of those action bars. Here, I create now a new body, which is my brake pad, because you will see that in this particular way of working, I will just, as a concept level, just work in part design, in one part, okay? And create multiple bodies, which will be, in fact, my future parts within a given assembly. And you will see how easy we can create from a part with bodies, an assembly with parts. Let's have a look, but let's first continue the job. Here we go. I create a sketch. I design my sketch. You know, I guess now you are familiar with that. It's very easily done. And I will just create another, the shape of my pad. You see, as I click on my shape, I can create a pad. Here we go. And this is in my brake pad, another body. So I continue the job. I create the exact brake pad after having created the pad support. So I have now three bodies, but I also created the cylinders, which will push on the pad support, and a pin which is guiding the pad support to push the brake pad. Okay, those are all my bodies. Now I just want to start to just detail or refine a little bit more the main housing of the brake caliper. But before that, I can use, very simply, wall thickness analysis. I am in part design, and here I just detect that there are some areas where are a little bit too thin. Okay, no problem. I will just work and turn on a clipping. This is also very cool in CATIA, in 3DEXPERIENCE CATIA, the clipping tool. So you select a clipping plane, and this clipping view is permanent. Okay, you can continue to work at any time with this clipping view. Quite useful in this particular case. Of course, at any time, you can also turn off the clipping view. Here we go. Now I just zoom in. Something very important, as you see here, I click on these faces and I selected this small footprints icon. And this is in fact a way to navigate with the parents and the children of this feature, or this face. And here, one of the parent is a sketch. So I can see that I can automatically display the sketch in 3D. I'm not forced to go to the 3D plane which was containing the sketch, and I can change, for example, this radius 14 to 16 to just make it thicker. Here we go. I will turn off the clipping because now I'm fine, and I just double check my design by running another wall thickness analysis. Looks good to me. There is no more red area with thin area in this portion of the solid. Now I use another command which is called remove face. It is in my action pad because I quite using this a lot, at least Daniel as a user. So I take those faces, remove, and the solid is updated accordingly. And I will continue the job. Here we go. And I will add some holes, okay? So after having added a small pad, I will first start to create a fillet. You will see how easy it is to create a fillet. I just click on an edge. As I click on an edge, the fillet command is prompted. I will use the same fillet on the two edges. And you can see I have a dynamic display of the fillet, and I can change quickly the value of the fillet to the one I was looking for. No dialog box popping up, filling the screen with something that hide the 3D to my view. Now let's go and continue the job. And what I'm doing here right now is just cutting this piece into symmetrical pieces. Okay, so it's very simple. I copy paste my body as result with link in a part. And then we'll cut out the first part and cut on the other side the other part. So I will have a lower brake caliper and an upper brake caliper, two bodies, which are symmetrical. Okay, so this is a brake caliper body, lower side, and the brake caliper upper side body. Here we go. Looks fine to me. And in this particular situation, I will add the holes. Okay, so here I select a face, I select a point, so I will create a hole, which is a up to last hole. Okay, with a given diameter 6. Here we go. I will do the same at this particular location, at this point here. Perfect. And I will do another one here at this particular location. I'm almost fine, but as you can see, this hole is not very good, okay? So I would like to replace this hole by a counterboard hole, which is more, makes sense to add a counterboard here, okay? So I just select the hole, change the parameters, use the standard I would like to use for because all those are standardized, of course, the dimension and the fillets and all this stuff. And now this feature hole is quite complex. It has a lot of different attributes. And with a simple click, you will see, I will use a semantic painter. So I click on the hole. It's a feature hole. It works also on other feature of 3DEXPERIENCE CATIA part design. I have this semantic painter here. It's like if I was copying not the color, but the semantic, the feature parameters of this hole. And then I can drop the same parameters to the other holes in my pad. Here we go. Very, very simple, very, very useful. Looks nice to me. Obviously, this part will be casted, so not milled. So now I start to enter into the detailed design of this part, and I will just create some draft. So you can use a classical draft command if you are familiar with CATIA v5, the draft command of CATIA v5, but it's very similar. So you select the face you would like to draft, you will select the pulling direction, the draft direction, you select the neutral surface and an angle. Here I will put 5 degrees or 3 degrees. There we go. Let's put 3. This is my draft, but what is nice in 3DEXPERIENCE CATIA is that we can do exactly the same for the complete part in one shot. It's called auto draft. So you select the auto draft command, you type in the same value, the angle, the pulling direction, and also you have to select the faces you do not want to be drafted. In my particular cases, all the holes. So I just select them, those will not be drafted, but every other face will be drafted, okay, in one shot, in one feature. Nice job. I have to do the same on the other direction. So select my angle, the same angle, in this case, select my pulling direction, opposite direction, of course. Select the faces I don't want to be drafted, and of course, the parting element. Here we go. Simple clicks, one command, one feature. This is my parting element. Looks good to me. Nice job. Okay. Just do a wall thickness analysis. Sorry, not a wall thickness, a draft analysis to check that everything's fine. Okay, the draft are on the right side. They have the right angle, so perfect. And to finish the job, I will also use a magic command of CATIA, which is auto fillet. 3DEXPERIENCE CATIA auto fillet. Those fillets are not functional fillets. I just manufacturing fillet. I just want to put a fillet of 1 millimeter on every single sharp edge of this design. It's exactly what this command will do. But you have to select the faces you do not want to be filleted, obviously, all the holes in my cases. Everything else will be rounded. Again, one single feature. If you have to do the same job without this command, it's probably take you much more time than me. So I put a 1 millimeter fillet everywhere. The command has not been accelerated. It's really the time it takes to do. Here we go. And every single sharp edge has been rounded. So my part is ready to be casted. Just to finish, I will add a small text, a small engraving. Can be an emboss, but here I will put an engraving. So it's also a capability which is available in 3DEXPERIENCE CATIA. You type in the text, you select the font, you select the dimension, you position and you constrain the text because this is a capability of the sketcher. So you have to position it versus, for example, an edge of a part. There we go. And then what I will do once the text is located at the right position, I will just project it and create, in fact, a small pocket. I could have created a pad if I wanted not an engraving, but an embossing. Here we go. Perfect. Good job. If I want to, for example, share with my suppliers, my colleagues, my customer, a nice, let's say, fancy view of this product, I can again change not the ambience, but the style of my display. For example, this type of display, or why not, old-fashioned stuff, but why not to show the part and maybe use it for a marketing purpose. Let's go back to the traditional design style. So I have my various elements, my various bodies for my assembly. And then I will use the magic command of 3DEXPERIENCE CATIA called distribute. If you look at this table, you will see all the content of the spec tree. All feature will be there. Of course, I don't want to distribute the skeleton or axis system or whatever. So I will just select the bodies. So I just select the bodies. So I will just remove some of the feature. And in one command, CATIA is creating an assembly, distributing in every single part all those bodies. It's very cool. If you have, again, to do that traditionally, it will take a little bit more time. So it's what you saw here was a very nice way of creating 3D models and assemblies by just starting from a conceptual part, because it's easy to modify. If you do design change, it will be much more easier and faster to update and so on and so on. And then once I have my assembly, I can use, for example, a very nice capability, which is a symmetry mirror or symmetry capability of assembly design, where you can select the part which have to be mirrored. Either it's really a mirror part or the same part, but rotated and translated, because it will be the same reference in the bill of material. And then I do for you saw for the cylinders, there are two symmetries along two different planes. So very easily, you finalize your design of your assembly to make something exactly matching your request. And we will finish the design of this assembly by adding some, what we call engineering connection, to make a quick kinematic analysis of this assembly. Let's see how it works. So very easily, you can define constraints. Okay, for example, this is fixed. This is also fixed together. Okay, so you will see what we are doing. Okay, the idea is that the cylinders which are inside this body are pushing the pad support, which is pushing the brake pad. Okay, along the guide. So here, just by using again the pop-up menu, which are again popping up. Sorry, once I selected the face, I can select the type of engineering connection I want, or let's say the type of connection I want between the parts. Okay, here I will again fix them together. This one and this one, fix them together, because one is pushing the other, stick to the other. Then I define the, just hide what I don't need, but I define, for example, a coincidence between this cylinder and the hole where it is guided. So I select the face. I say coincidence with this axis, which is the axis of the hole. I do the same for the other cylinder. So, and as you can see, as I click on a cylindrical face, it created here a cylindrical connection. Okay. I continue the job, because I have now to define the connection between the pins which are guiding the two brake pads. So those are coincidence, but it's not only coincidence that I want, because otherwise I will slide only. I will add another constraints, very let's say logical one. You will see which one. Okay. Again, no big dialog box popping up, just clicking on the 3D and selecting options. What I put here is, in fact, something different. Is I will add a contact. Okay, because in fact the cylinders are pushing and there is in contact with the pad. Okay, so once you select, for example, a contact on top of a cylindrical connection, it will convert, it will enrich the cylindrical definition and convert the cylindrical plus contact into a revolute connection. Okay, this is quite smart and quite nice. So you can easily define constraints between various parts inside your assembly, and what you will get for free is the kinematics. Compared to V5, where you define assembly constraints and then you enter to another app called Kinematic, where you define the kinematic joints, in 3DEXPERIENCE CATIA, everything is done only in one shot. Okay, and then you just have to add, for example, an input. I will select what part is moving and for what is the magnitude of the motion of this part, and you can display it. So you really get kinematics for free when you are designing an assembly with 3DEXPERIENCE CATIA. And of course, we can show this assembly in motion. We can analyze the motion within the complete context of my braking system. Let's move it. Just move the mechanism. Here we go. So that's it for my first part of this presentation. You saw how easily I could design not a simple part. There are drafts, there are a lot of fillet, there is some mechanism, there are connections, there are constraints, and it took me 17 minutes, okay? So not bad. Now, just to finish the presentation and this webinar, I will show you a little bit more advanced capability, but more regarding geometry than pure mechanical design. Let's go. Typical scenario is I receive a part from my supplier, which is this fork bracket, okay? So he sent me the part. It was this design here. And I want to convert here we go. I want to check if this part it's a new part. It's a new version of the designs supplied by my customer or suppliers. And but very strangely, just a set of surfaces. It's not a solid. So maybe there was some issue during the conversion, or maybe the data was not that good at the input. So I will just try to join those set of surfaces. You can see there is a geometrical set for those who are familiar with CATIA. So I just join them. Okay, no problem. Looks like there is no problem. And then I will create a closed surface. So convert this set of surfaces which are joined into a solid. Ah, there is an issue. Okay, you cannot create a solid out of that. Not a problem. So I will just now use a very nice command which is in 3DEXPERIENCE CATIA, which is called the local join. Okay. First of all, I just display where are the problems. Okay, you can see here in green there are some there are some gaps between the surfaces, so we cannot stitch them together at a given accuracy. Again, not a problem. Let's go and use this nice command called local healing. What it will do, it's very simple. It will just heal locally the surfaces. It will not touch the rest of the surfaces, just those ones which need to be put together. But maybe you can see there is here a plane. I don't want the plane to be modified. Okay, the plane is a plane, so I will freeze the plane. So the plane will stay as a plane. So I freeze this plane, planar surface, and I will just move the other one. Okay. Now I will just add joining distance. Here we go. And if I create now my closed surface to make a solid, voila, it's working fine. That's the very first stuff you can do. The second stuff that you can do is that, okay, I receive a new version. I clean because there were some issues. Now I want to compare what has been modified between my previous version, the one I showed you there at the very beginning of the presentation, and this one that I just clean. So there is a nice command as well in 3DEXPERIENCE CATIA called compare. So I compare the first one with the previous one. And you can see here in the screen a special window where I can display the differences between the first part and the new version. And I can highlight if there are some differences and where are those differences. You can see here that there is a small pocket which has been added in one version versus the other. Okay. Now what is very nice is that I can automatically extract from the new version what needs to be added to the previous one. Okay. I will extract just what is necessary. I will keep the rest of the geometry. It's what we call here when we do the compute. So I will just extract the faces which are different, which is the big one and the small pockets here. Okay. Here we go. I select these options. And now you will see in the spec tree that I have some 3 geometrical sets with what is identical between the two versions, what is specific to the first version, what is specific to the new version. I will just hide what is not necessary. Just keep what has been changed. You see here in yellow. And what I will do, I will just sew this new surface or set of surfaces, which is a planar surfaces with the oblong, to the previous solid. So this is a sew command. And automatically we create the update of the solid. Very nice capability. It helps a lot because sometimes the differences are not so obvious between one version of the model and the second version. And of course, I can work and check my part in my context. So that's it for me. The conclusion. First, I hope you understood that 3DEXPERIENCE CATIA has a very intuitive user interface. You pick in 3D and you are guided. It's very effective, very few mouse clicks, very small mouse mileage. Don't go from one side to the other side of the screen and so on. And of course, and on top of that, you can even customize more than what is proposed by default if you have very, very particular command that you are using a lot. The display is very fast and high quality, and you have very advanced modeling capabilities, which is one of the richness of CATIA, but continue to be a richness of 3DEXPERIENCE CATIA. So, and what are the benefits for you guys and ladies? Casual user, it's easy to use. So casual user do not spend a lot of time just to know what to do and so on in front of the screen. Expert user are very productive because they don't spend too much time by opening, closing dialog box and just focused on the 3D and clicking on entities, and CATIA is popping up with the right commands. And for existing CATIA v5 user, it's very simple to learn and it's very quick to master, okay? And we measured that the productivity when you are designing solids or surfaces can vary between 20 to 50%. So it's a great advantage to move from 3DEXPERIENCE CATIA, or sorry, to go to 3DEXPERIENCE CATIA, wherever you are starting from, and don't wait. Thank you very much for your attention.